Alright friends, a big hello to everyone. We're gonna have many tests today. It's already 12 noon on my stream, unfortunately. Yeah, got a late start today. Regarding this equipment, the xTool F2 Ultra, the Jesus file, it's right here, over here on the left side. The screen is too big, nothing fits. Let me show you the size of this file. Now, I'm not bragging by any means, not showing off, just demonstrating. Where are the properties here? Properties. 1.34 megabytes. This is a file for 3D engraving, specifically on the xTool F2 Ultra. Well, the fact remains, the size of the file that, well, exists. Here it is, our finished file. Let's not load that. Let's load a completely new workspace. Plus sign at the top. Transition. By the way, the machine connected automatically via Wi-Fi. In that regard, I love equipment that connects like that. At least, I don't know, the data transfer protocol has changed, and it all loads much faster. Open the project on the desktop. Jesus, X2. Oh, I mean the xTool F2 Ultra. We're hitting the classic size. We ran some tests a bit earlier. I'll tweak it to a certain point where everything turns out really great. Why am I testing here? Now, some people will ask me, why am I testing here? And why will I test this 5 or 6 times at 30 millimeters? Why don't I do it, say in that same laser pecker? The explanation is very simple. Here, the file is loaded directly into the machine's module, into the control panel, the DSP remote. And after that, I don't need the computer anymore. I can turn it off, forget it, and just repeat the process by pressing the key twice. And it will engrave forever and ever. If we're talking about that same Laser Pecker 5, well, its algorithm is different, meaning the program slices something there and sends each layer individually, over Wi-Fi to the machine. And such an engraving process takes a day, or even 2. So I'm ruling out that option. No matter what speed we set, even if we set, although there isn't even a speed adjustment here. Unfortunately, yes. That's a sad note, of course, but it's all here. So I'll say right away, the previous stone was burned at 60% power. That turned out to be a lot, way too much. Plus look, the settings here, how professional machines differ, again, let's say from the xTool F2 Ultra, Laser Pecker, and all the other machines. Now, someone might get offended, someone's butt might explode, it doesn't matter. What matters is that the settings have already been decided for you by the company in the main office. Basically, you're just provided with equipment that's already set up, and no matter what speed you choose your algorithm, ignition, start, and laser off power will be restored automatically by the algorithm built into the program. That's it. There are no other options here. On machines like those Chinese ones, running under ESCAD 2.0, light burn, fiber lasers, I don't know, some diode ones, where we can still adjust the start and laser off power parameters, NTC. We can set finer equipment parameters and get this detailed part here. Make some specific offsets, like in laser emboss for example, yeah, there. Well, the settings can be made extremely fine. Laser Emboss also has a bunch of its own glitches, but the program there is somewhat similar to the simplicity of working here. That is, filling is automatic, everything is automatic. You just change the power, speed, and off you go. So today, we'll work at speeds of 3000, 45% power, maybe a little bit more. I'll play around with the power just a bit, test it on 3 or 4 different stones, maybe 5 stones. Rotation angle 15 degrees. We won't change it, lines per centimeter, we set the maximum value to 300. Like a tractor driver, 1 pass, frequency. Since we've reduced the speed to 3000, now we need a calculator. There's been a lot of work since morning. My head is already spinning. Let's type it in. Calculator. With such a lens with a working field of 220 by 220 millimeters, what is our task? We have a spot size equal to about 50 microns, so that's equal, let's say. And there is a movement speed of 3000 millimeters per second. So now we just have to calculate our frequency. That is, multiply this value by the frequency and get some number of spots per millimeter. Let's multiply by 110,000 equals, we get 5.5. Half a meter overlap for each spot, so we can reduce the frequency, well, not by half, of course. Reduce the frequency to somewhere around 80, most likely, or we'll do it differently. Look, we take, let's say, we have a distance of 3,000 millimeters per second. So here, I haven't seen the visualization of the spot size relative to the frequency range. Basically, how we do it, 3,000 meters per second, we divide by 50 microns because in our case here, it doesn't matter. Cupels control, it's the frequency range that matters, the densest and most powerful cupels possible. So we get 60 kilohertz, which is what we can use in our case for working with stone. To have a slight overlap of spots, let's set the value to 70 kilohertz, so the math says so. There's no other way here. Maybe in the future they'll add a visualization here, like in XCAD maybe. It's here. Well, basically it's not needed at all, really, because no one is going to calculate or figure anything out here and they'll just work like they did before. We set the value to 70 kilohertz. Basically, that's it. Every n layers move down. Now here, of course, the thing is that the lowering of the z-axis during engraving will directly depend, once again, on our stone, on our machine, our power, the pass density. So there will be many factors. Let's open that same calculator. So we have 256 layers. We divide that by 2, which equals 128. And then naturally, we multiply by 0.01 millimeters. In the end, we get 1.28 millimeters that it will drop down. Whether it will actually happen like that or not, I don't know. I'm telling you straight. But at least we'll work with these specific parameters today, since we've lowered the power and lowered the speed. I think it'll definitely drop by about 2 millimeters. We'll see if there's any defocusing. Our next step, the stone is on the work table, we click the ruler, and the LiDAR will now measure the distance to our stone. The stone seems to be level, so we've positioned it as straight as possible so it's visually clear. So we press the control button and pull it upwards. Right, now we position the image however it's convenient for us, so let's say in this spot right here. We won't be clicking anything else here, we just need to hit process, and the process has started. Yes, it's a long intro, but with explanations, because most of you, when working on these machines, you need explanations as to why it's done this way. And now for the main highlight, let's open the calculator again. Engraving time is 56 minutes and 57 seconds. Now for clarity, bring out the calculator, as they say. Look, we had a value of 4,000 millimeters per second, and the time was about 53 minutes. We divide 53 minutes, divide by 4, meaning 4,000, right? That gives us 13 minutes per thousand, and we multiply by 3. I calculated that wrong, Uncle Fyodor. Our speed was higher before, and now we've made it lower. Let me run the math in my head and I'll tell you how to calculate it correctly. Yeah, it wasn't the machine's fault, as they say. It was the operator. Once more, we divide 53 minutes by 4, which equals 13.25. And we add the value we had before. So for this time, well, logically, the engraving time should have, in theory, increased because we have, let's say, reduced the speed. It's an imprecise calculation. My math is a bit off today. Monday's a tough day. Let's just say that, yeah. So let's say plus 52 minutes equals 65 or so, which is 1 hour and 5 minutes. Our actual time comes out to 56. So the difference only changed by, roughly speaking, 4 minutes with the change in speed. Why is that? I can't say for sure because there's an algorithm. After all, like jump speed, and there's an algorithm like polygon TC, which is the beam's transition along polygonal lines, meaning the wait time at polygonal line points, all the transitions, everything we have in polygonal lines or corner point. This is all also waiting time, which is also set by the machine. Plus, there's this thing where the mirrors, when they reach the edge, they don't just reach it and stop. I mean, a final mirror deceleration time and an acceleration time. No mirror starts abruptly, it just looks that way to us, but in reality, there's an acceleration time for these mirrors, which is also factored in here. What it's set to? Specifically here, we don't know. So basically, based on all this data, when we reduced the time, the engraving time didn't really change much. So I'll conclude that, after all, Most of the parameters that are behind the scenes, inaccessible to regular users, have a huge impact on the engraving time of our 3D model, 3D template, and, again, depending on the material. So let's hit start. I'll say right away, this crappy, damn it, yeah. What I didn't say again, look, yeah, confirm. Let's hit cancel. What I didn't do here, yeah, confirm cancel, finish. This is very important for any 3D engraving. I just forgot again, almost made the same mistake. It's the same error made over and over again. Why this is done in 3D engraving, specifically in xTool Studio, I don't know. I have no idea. By the way, notice that I have these special aluminum guide boards here that will collect all the dust so that during engraving, it flies right into that pipe. So then I could also film a video for you about how this whole process will go. So why is this automation done? In 3D engraving? Yeah, so look, we open the bottom panel on the right, open where the process is, arrow up, there are processing settings, bypass mode, uncheck that please. It won't do anything for you here. Processing path? Processing path? The processing path is the trajectory of the laser head. The head, yeah. Damn it, what head? No way, damn it. It's a galvanometric scanner. It's mirrors, so, well, damn, it's strange, of course. On the material surface, used for precise position control. But we don't really need that here. And here's a very important thing. Processing path. Automatic planning. What is automatic planning in our case? It's when a machine or the software itself will just randomly pick these 256 layers that we specified in this part. Any layer, and it will engrave it randomly as it sees fit. For 3D engraving, that doesn't work. In our case, engraving happens either from top to bottom, from white to black, or from black to white, upwards. There can't be any other options here. Why this function is needed here, I have no idea. We need to get rid of there. User definition is mandatory. If in other regular 2D engravings, when you have tons of models, you can set automatic planning, it wouldn't hurt us. But in this case, user definition is mandatory. Uncheck by layer, uncheck smart mode. We'll figure it out ourselves without smart modes. I'm telling you straight. Yeah, that's a bug that's in here. No, it's that. I've run into this issue many times, and I almost did just now too. Actually, it's good we opened the project that already saved this data. The project, I'll say it again, I saved the corrected project for sure. On the Telegram channel, so go check it out. All the links are in the description. So we hit process. The calculation time doesn't matter now. We know it'll take 56 minutes. Maybe with automatic planning, it would be a bit faster, a bit snappier. But it doesn't matter to us because automatic planning just messes things up for us, so we're skipping it. The next thing we have here. We removed the internal fan that was built into this machine. There's an option to take it out and remove it. We're confirming, yes, that we're working without the fan, but there's a slight downside here. During the engraving process, the same information will be displayed directly on the machine's DSP controller, right over here. And unfortunately, there are two timers, the total time and countdown, and the actual elapsed time. When this message pops up, we unfortunately lose that time, and we won't be able to see it. Let's move on to the engraving process. Let's look at the results. I'll test several different stones using the exact same parameters. If something goes wrong, then we'll adjust, fix it, and change the modification. We'll most likely change the modification. For the layer thickness, there's plenty of room for adjustment and things to work on. And I might change the power parameters specifically, meaning we'll adjust the power from 45, likely upwards, balancing it up to 60. Since we also changed the frequency range, there's plenty of room to balance it. Let's take a look at the results. Let's start with the previous engravings done earlier. Speed 4000, power 60. The process reached vitrification due to the high power, and, well, some issues cropped up here too, as it turns out. The issues are related to the start TC laser off. To demonstrate it visually, let's show it this way. When the beam goes from start to edge, in the first pass, it goes strictly from edge to edge. Then the layout selects the internal parts. And here we get the following result. The edge will always be scorched. And since we have steps, those steps are formed from baked stone, which is mineral wool, so it will turn out white. At least that's what happened here. A similar situation here, but we lowered the power down to 45%. The frequency. The stone is also a bit different in properties and structure, so the quality is pretty good, but there's a small issue again. Moving on to another stone. The stone looks like volcanic rock. The same situation with vitrification in the formation of mineral wool. Because the engraving is being done on material with an incorrect, I'd say start TC laser off, you can really see the edges burning during engraving. I think those who use these machines will see the exact same thing. And because of that, this white dust or white mineral wool forms on this little stone. You can, of course, remove it, but man, I'd like to get a finished result right away. So, what actions can be taken? One action is to exclude stones that mineralize or turn into cotton or melt or boil. Right, and exclude that option. Change in the power. But then again, look, the stone turned out okay, but we have these little bumps here. There they are. So, with insufficient power on this stone, it doesn't clear out. Some, I don't know, inclusion, say, of that same sand or something else. So there will be a whole bunch of such inclusions. It was the same thing here. See, we didn't have this on other stones, but completely different equipment was used there. So is it possible to do high quality 3D? Yes, it is. Is it possible to do it fast? Yes, also possible. Increasing the speed there or adding speed doesn't add much for us here. I mean, changing from 3000 millimeters per second to 4000 millimeters per second, we only save 4 minutes, so not a quarter of the time, but exactly 4 minutes. You have to understand that too. I hope this video is useful to someone after all, because a lot of time is spent on all of this. A lot of tests are being conducted. The result, well, is obvious. The quality is good. You can work with this too. That's it, guys. Wishing you all the best, lots of cash, and bye-bye, everyone.